5A, we're going to look at complex and imaginary numbers. Okay, so imaginary numbers, the symbol there is the letter I. Okay, so an imaginary number is the square root of -1. Okay, so up until this point in your math career, you have been told that you are not allowed to take the square root of a negative number, but now you're going to learn how to, and we're going to do it using imaginary numbers, and I is the imaginary number. So I is the square root of -1, and then I squared is -1. Okay, so complex numbers then are numbers in the form a plus bi, where I is an imaginary number. Okay, so now anytime we have something with an imaginary number in it, that's going to be called a complex number. Okay, real numbers are complex numbers with b equals 0, so without an I. All the numbers you've been dealing with your entire life. Okay, so if I had, 2, that's a real number. Okay, a complex number would be something like 2 plus 3i. That's a complex number. And then pure imaginary numbers are ones that don't have the a part. So something like 7i. That would be a pure imaginary number because it doesn't have something added or subtracted to it. Okay. So we can use a negative number to simplify square roots when we have the square root of a negative number. So for example, if I were going to take the square root of -16, okay, I'm going to break that apart as the square root of -1 times the square root of 16. The square root of -1 is I. The square root of 16 is 4. So the square root of -16 simplifies to 4i. Okay, we can do the same thing with numbers that aren't perfect squares. So if I had -24, I would break that apart as I'm always going to do -1, okay, whenever I have a negative number. And then 24 is 4 times 6, and 4 is my perfect square. So I have I, that's the square root of -1. 2 is the square root of 4, and then the square root of 6 I can't simplify anymore. So I have 2 times I. 2i square root of 6, that would be the simplified version of the square root of -24. So we can simplify powers of I because it follows a pattern. So this is the pattern. It always goes I to the first is just I, obviously. I squared is -1. I to the third was equal to -I. And then I to the fourth is equal to +1. Okay, so this is the pattern. All right, but if you got into really big numbers, like here 103, I don't think you want to write this pattern out all the way down to 103 to see where this would land. So the process is we're going to divide the power, the exponent, by 4, and then we're going to use the remainder. So this is I to the first power. If I did 1 divided by 4, that would equal 0.25. All right, and what that means is any number that has a remainder of 0.25, okay, it's going to be equal to I. If I did 2 divided by 4, that would be 0.5. So anything that I divide and get 0.5 is equal to -1. 3 divided by 4 would be 0.75. So anything with 0.75 as a remainder is going to be equal to -I. And then 4 divided by 4, of course, would be 1. So anything with no remainder, right, anything that's a whole number, is going to be equal to 1. So the way we do this is we take the exponent, 20, and we divide that by 4. 20 divided by 4 is 5. So I, with no remainder, it's a whole number, so I to the 20th is equal to 1. All right, same thing here. If I did 103 divided by 4, that's going to be equal to 25.75. So if I have a remainder of 0.75, that is equal to -I. All right, and then last thing we're going to look at is adding and subtracting complex numbers. It's just like when you did adding and subtracting polynomials in Algebra 1. All we're going to do is combine like terms. So anything I have, now you don't have to do this step, but I'm just going to show you. If I have something in parentheses, plus just means everything here stays the same. All right. So now, what are my like terms? Well, I have -3i and +3i, so I can combine those. If I do that, negative 3 plus 3 is 0, so those terms cancel each other out. Right? My other like terms are 4 and negative 4. Well, 4 minus 4 is 0, so this whole thing is equal to 0. Right? In this one, I have minus, so we're going to treat this like a negative 1 and distribute that. So I have still 5 minus 3i, and then negative 1 times negative 2 would be positive 2, and negative 1 times positive 4 would be negative 4i. Okay, so here I have 5 plus 2. Those are like terms that I can combine, and that's 7. And then I have negative 3i minus 4i. Those are like terms that I can combine, and that would be negative 7i. This would be as simplified as it can get. I can't put these two together because this term has an I and that one does not.